Okay, many stages, your friend said. Okay, Bezen said many stage. Yes, correct. Okay, so what you have done in the past of BJT and MOSFET, where you have single stage, okay, you analyze the AC analysis. For the single stage, you find the input impedance, the output impedance, the voltage gain, and everything. So in multi-stage, you're gonna have two stages. Okay, not only one amplifier, not only one BJT amplifier, two BJT amplifier combined together. Okay, two MOSFET amplifier combined together. So can you imagine your AC analysis? All right. So, but since you have very clear on the AC analysis of BJT and MOSFET, so multi-stage is quite easy and straightforward actually. Okay. So it's just the concept. The idea is you combine two stage only. Okay. In this syllabus, only two stage means you can imagine of the BJT, two amplifier BJT, and also the AC analysis gonna have long drawing of the AC analysis. Okay, two AC analysis, two stages. Okay, in this case. Okay, a good news is for the multi-stage amplifier, only mid-band frequency. Okay, only mid-band frequency. There is no low frequency or high frequency. Okay, there are two types of the multi-stage. One is RC couple, means that the resistor to capacitor couple, and also the direct couple. So since you want to combine between one BJT amplifier and one BJT amplifier, or one MOSFET amplifier to one MOSFET amplifier, there are two types to combine it. Okay, the first type is RC couple, by connect it the two by using resistor or capacitor, or the other one is by connect the two transistor amplifier by using direct couple. No resistor, no capacitor, just a wire. Okay. Okay, multi-stage amplifier, the output of one amplifier is the input of the next amplifier. Okay, and the overall voltage gain is determined by the product gain of the individual stages. For example, you have done in the BJT or MOSFET, you find the voltage gain, the AV. Okay, that is for the single stage, and then you're gonna have to find the AV for another stage. So what will be the total voltage gain, the overall? So you have to multiply the first stage of the voltage gain with the second stage of the voltage gain. Okay, and the DC bias circuit are isolated from each other by coupling capacitor, and the DC calculation are independent of the cascading. Okay, we'll look at the example. Okay, and the AC calculation for gain and impedance are interdependent. Okay, for example, this triangle shape means amplifier. Inside this amplifier is your amplifier circuit, like voltage divider circuit or fixed bias circuit or whatever, MOSFET circuit, voltage divider MOSFET circuit. So you're gonna have 1, 2, and 3. So in your syllabus, just 2. Okay, so just want to show you what is meant by the multi-stage. Okay, so we have one stage, two stage, and three stage. Okay, for the one stage, you want to have to find the voltage gain for the first stage, and then if you have second stage, then you have to find the voltage gain of the second stage, and so on. Okay, so you know that AV, okay, the voltage gain is equal to the if you still remember, AV is equal to the V out over V in. Okay. Okay, so this is the V in one, and this is the V out one, right? So to find the AV1, okay, AV1 is equal to the V out one over V in one, okay, which is equal to the 36 milli over 900 micro. Okay, so that is for the AV1. Okay, how about for the AV2? Okay, okay, means that, so this is the V in 2, this is V out 2. Okay, so AV2 means V out 2 over V in 2. Okay, so if you can see from here, V out 1 and V in 2 is in a straight line. So actually, V out 1 is equal to the V in 2. So this is what this statement means, okay, this statement means the output of one amplifier is the input of the next amplifier. See, the output of stage 1 is equal to the input of stage 2. Okay, therefore AV2 is equal to the 1.25 volt, okay, over 36 millivolt. Okay, so this is what it meant. And so on for the stage 3, V in 3, and then this is V out 3. So this is AV3, okay, V out 3 over V in 3. All right, so this one is equal to the 21 over 1.25. Okay, right? So what would be the overall? Okay, overall voltage. So overall voltage means the product of gains of the individual stages. So overall means the total. So AV total is equal to the AV1 times AV2, okay, times AV3, okay, for the case of this example, right? So AV1 is equal to the AV2 plus AV1, AV all equal to AV1 times AV2. All right. So, or if you want to do more straightforward, so voltage gain over here, okay, is equal to the V out 3 over V in 1. Say either way, okay, either way. If you have all the values. If not, then you're going to find each of these AV1, AV2, and AV3. If not, then you can use straight away like this. Okay. All right, so coupling multistage has two types. Okay, one, it is combined by using capacitor, okay, between stage 1 and stage 2. So like this, okay, between stage 1, this is stage 1, this is stage 2, it is combined by using a capacitor, for example, in between it. Okay, or it can be a direct coupling, okay, no capacitor, okay, no capacitor, okay, just by using wire like that, okay, just by using wire. All right, so that is direct coupling. Okay, so this is how it looks like. Okay, this is your future. No, 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 I'm just kidding. Okay, so this is how it looks like for the multi-stage. Okay, so can you see your future in analyzing both the stages? No, don't be sad, I'm just kidding. It is easy because you already know what you need to do. Okay, you already know for the single stage, then you have another stage. Okay, your life is not end here. Okay, so you have two stages. Okay, so RC couple means it is this is stage 1. Usually stage is referring as the Q1, stage 1. This is stage 2, Q2. As you can see it is combined by using a capacitor over here. So this is the type of RC couple BJT amplifier. Now, my dear student, can you tell me the first stage, what common is this of the first stage? Can you tell me? Is it CB, CC, or copy paste?
CE,
C?
CC, CE,
CE, CA.
CE. This is CE. Okay, so look at it. Okay, look at this. So that's why I asked. Okay, so the input of the first stage. Okay, so this is the input. Okay, input of your first stage is connecting to the base. Okay, so where is the output? The output of first stage, okay, must be connect to the input of the second stage. Okay, so this is what it meant. Okay, so output one amplifier is the input of the next amplifier. So input of the next amplifier is this one. Okay, this is the input. So this is the output for first amplifier. So what's left here? So left is emitter. That's why this is common emitter. All right. So for the second stage, what common?
CE,
Okay, correct. Okay. So this is collector, this is base. The input is at the base, the output is at the load. So this is the output, okay, at collector. And what's left is emitter. Therefore, this is common emitter. So this is multi-stage amplifier between common emitter and common emitter. All right. Okay. All right. So let's take a look on the example. Okay. So not example. So this is what it looks like. Okay. Okay, so you still remember the common emitters? So common emitter, you have R pi, you have GMV pi, and then you have to put everything from here at the input you have. Okay, I think let's do it together. Let's do it together. Okay. Can you see?
Yes.
Yes.
Okay. So the AC analysis. Okay. So this is common emitter and common emitter. So first thing for the AC analysis, okay, what you do for the first thing for the AC analysis, all capacitor, what happened? All capacitor, what happened? Short circuit, correct. Okay, and DC voltage,
Rounded.
correct. Okay, so DC voltage grounded. Okay, and capacitor shorted. So let's we short all the capacitor. So we have capacitor 1. Okay, and then capacitor 2, this one will be shorted as well. And CE also, CE1 will be shorted. What happened to RE1?
Also, it
Short.
Yes, correct. Okay, and then C3 is short circuit. Okay, and CE2 also short circuit. What happened to RE2?
Short circuit.
Short circuit. Okay. All right. Okay. Okay. So let's do it. Okay. So common emitter and common emitter. Okay. First thing, okay, you have to, you know that when you have common emitter, you have R pi. Okay, R pi. And then you know that your ground is emitter, your base is at the input, and don't forget you have your GM V pi. Still remember this? This is your collector. Okay. All right. Don't forget that you have V pi over here. Okay. V pi. Right. Why my R is down there? R pi. Okay. So let's take a look at the base. So this is Q1. This is Q1. So this is base. This is collector. This is emitter. All right. So emitter now straight to the ground. So emitter to the ground. Okay. All right. So at the base, okay, at the base, what do you have here at the base? So at the base, you have one R1 to the ground, R2 to the ground. Okay, so you have R1 to the ground and R2 to the ground. Okay, therefore R1 and R2 will become,
parallel.
yes, parallel. Okay, R1 parallel with R2. Okay, and then you have capacitor C1 short circuit, and then you have RS over there, that is RS, and also VS. All right. Okay. All right. So we've done for the stage 1. Okay. Not yet. Not yet done for the stage 1. Okay. So what else left? What else left at the stage 1?
RC1.
Yes, RC1. Correct. RC1 to the ground.
Ground.
Okay, to the ground. So that is your RC1. All right. Okay. So next is your stage 2. Okay, stage 2. Okay, stage 2, okay, will be started at the base, okay, and Q2, since this is common emitter. So let's draw the hybrid pi model first. So you have R pi, okay, and you have here I don't want to draw very near from here. So make it a little bit far over here. Okay. Is it too far? GMV pi. Oh, yeah. Yeah. Okay. So you have R pi. Okay. So this is your Q2. Okay. This is your R pi plus minus V pi 2 R pi 2. Okay. And you have here GM V pi 2. Right? Oh, no. No, 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 no. Not enough. Okay. So, here. This is R pi 2. And then you have GMV pi 2. Okay, this is Q2. This is base. This is collector. Okay, this is emitter to the ground. Okay, all right, that's it. Okay, this is V pi 2. Okay, so at the base over here, at the base 2, at the Q2, you have R3 parallel with, so R3 to the ground. Okay, R3 to the ground, and R4 also to the ground from the base. Okay, same node over here and meeting same node at the ground. Therefore, R3 and R4 are parallel. Okay, are parallel. So this is R3 parallel with R4. Right? And at the collector, as you can see from here, collector, you have RC2 to the ground. Okay, RC2. Sorry, this is RC2 to the ground. Okay, what else do you have here at the collector? Other than RC2, you also have
RL.
RL. RL. Okay, RL. Okay, plus minus V out. All right, that's it. Okay, so this is your V in. Okay, V in, and that is your V out. Okay, so you have stage 1 Q1 and stage 2 Q2. Okay, so you have also at the first stage, this is your Z in 1. Okay, and this is your Z out 1. Okay, next to Z out 1 is Z in 2, and finally at RC2 is your Z out 2. Okay, so you have everything there. Okay, so this is how it look like for the AC analysis circuit for the multi-stage RC couple. Okay, so let's derive for the Z in 1, Z in 2, AV and everything. But before that, do you have any question? I need to copy this to make to the next slide. Give me time to screenshot here. Wait. Okay. Where is it? Okay. All right. Okay. So that is the AC equivalent circuit. Okay. All right. Okay. Let's find Z in. Okay. So can someone say what is Z in? Z in 1? What you can see from there? Z in 1?
R1 parallel R2 parallel R5.
Yes. Okay. So for Z in 1, R1 parallel with R2 parallel with R pi. Okay. It is very straightforward. Okay. How about for Z1?
RC1.
Yes, okay, the thing that you see from here, okay, from here. So it is RC1, okay. How about Z in 2? Okay, Z in 2.
R3 parallel R4 parallel R2.
Again,
R3 parallel R4 parallel R2.
okay, R3 parallel with R4 parallel with R pi 2. Okay, see, you have many small signal parameter, right? Okay, so Z out 2 is RC2. Okay, all right. Okay, great. Now, okay, now, so let's find for the AV. Okay, so let's find for the AV1, okay, which is equal to the V out 1 over V in 1. Okay, so let's put where is V out 1. Okay, so this is V in 1. Okay, so this is V in 1. Okay, V out 1 is next to the RC1. Okay, so this is V out 1. Okay, and also at the same node, it is equal to V in 2.
Three.
All right. Yeah, yeah. And this is the V out, okay, which is equal to the V out 2 lah, basically. Okay, so V out is V out 2 over there at the back. Okay, so what is AV1? Someone? AV1, V out 1 over V in. So what is V out 1?
Negative GM
B
B pi
1.
RC1.
Okay, negative GM V pi 1. Sorry, I didn't put V pi 1 times
RC1.
Okay, so the voltage is when we have many resistor. If I said what is the V out 2, then you have to multiply all resistor, right? Because it's parallel. Say when you have parallel resistor, so the voltage across it is the total parallel resistor, not only at one resistor. Do you still remember? So V out 2 is negative GMV pi 2. If you do the common emitter single stage, you will say that it is RC2 parallel with RL. Remember that?
Yes.
Yes.
So same goes to here. What are the all resistor involved at this V out 1? So since this is in parallel, all the resistor parallel. So you have to include, the RC1 parallel with,
R3 R4.
yes, Z in 2. Am I right?
Yeah.
Yes.
Yes, correct. Okay. Okay, so divide with V in 1. So what is V in 1?
B pi 1.
Yes, V pi 1. V pi 1. Cancel out this one. So you're going to have negative GM RC1 parallel with Z in 2. Okay. All right. So AV2. Okay, AV2. V out 2 over V in 2. So what is V out 2? What is V out 2? Here at the back over here. So what is the
Negative
voltage?
GM B pi 2.
Times?
And RC2 parallel RL.
Yes, correct. Okay, RC2 parallel with RL. Okay, what is V in 2?
V pi 2.
Correct, V pi 2. Okay, V pi 2. Because I already wrote here with the, I don't know whether you can see, that's why I use different color. So this is V in 2 parallel with V pi 2. Therefore, V in 2 is equal to the V pi 2. And this one will be GM RC2 parallel with RL. Okay, so that is the analysis. Okay, so usually for the multi-stage, they will only ask you up to the impedance, the Z, and also the voltage gain. Okay, no current gain in here. So are you all clear on the multi-stage RC couple? Okay, so sorry doctor, why have to get again, need to read it. Sorry doctor, why have to get the parallel R again? Okay, Bezan. So in single stage, okay, in single stage, whatever stage, okay, common emitter ke apa-apa ke, whatever. So if you find the voltage, okay, so this is basic, okay. So I just want to draw with a different color. So if you have resistor 1, resistor 2, okay, and resistor 3, okay, R1, R2, and R3, and then you have whatever. So this is your current. So how you find V? So you have to find V. So voltage across V here is the voltage across R3 is equal to the voltage across voltage across R2 equal to the voltage across R1. So if you parallel these three resistors, so the voltage across it is still the same because it is a parallel resistor. Okay, so same goes to here. All these are in parallel. Okay, in the same node at the at the top, and same node to the ground. Okay, at the bottom. That's why you have to parallel when you find voltage across this node. So you have to to parallel all the resistor across the node. Okay, so in this case, V out 1 is equal to the V into whatever. So and then if you want to find the V out 1, what are the resistor across V out 1? Not only resistor RC1, you also have the same node over here, R3 parallel with R4, parallel with R pi 2, which is equal to the Z into lah. So since you have find the Z into. So therefore, V out 1, you have to multiply all resistor across the node. Okay, Behzan? Clear? Okay, so if you look at the output also, Behzan, so if you find the V out 2, okay, doesn't you have to multiply all resistor? Not only RC2, you have to parallel the RC2 with RL and then times the current. Okay, same goes to the V out 2. All right. Okay, so that's it for the first example. So this is on the RC couple between common emitter to common emitter. Okay, so all right, so this is example 1. So we will do it together. But first, okay, I'll give you take 5. Okay, take 5. Okay, you need to think. Okay, the first stage is what common. The second stage is what common. Okay, can you do it? 5 minutes. Is that okay? All right. Hello?
Yes.
Okay, doctor.
Okay, I left you
Yes,
with
teacher, we agree.
5 minutes with stage 1 white common, stage 2 white common. Okay. Hi all. Hello. Hello.
Betul.
Yes, madam.
Okay.
Yes.
All right. So what is the first stage? First stage. What is first stage? Q1. What common? So look at the input and output and everything. So this is, sorry for take
Common emitter.
longer
Common
time. Common,
emitter.
common emitter. Common emitter and bypass because there is no capacitor over there, right? So with RE. Okay. So the first one is common emitter. Okay, what is the second stage, student? So this is your gate. This is your drain and this is your source. So what is the second stage? What common?
Common gate.
Again? All right. Common what? Can't hear
Common
you. Okay. So for those who can't see it, okay, it is common source. Okay, common source. Okay, so let's look at the beginning. Okay.
Madam,
Yes.
the first one is common emitter.
The first one is not common emitter. Sorry. So let's take a
Common
look
collector.
together. Yes, common collector. Okay, common collector. Okay. So let's take a look at the. Thank you, Alex. So at the base. So at the input. Okay. So this is the input. Okay. So now input is connecting to the base. To the base. Okay. That is the input. Okay. Remember that I said the output of stage 1 is the input of stage 2. Now, which one is connected between stage 1 and stage 2? The emitter, right? This one, right? This one, right? So stage 1 of emitter connected to the gate of stage 2. Okay. Therefore, this is the output. Okay. This is the output 1. Okay. Output 1. Okay. All right. So what's left here now is
Collector.
Collector.
collector. Therefore, this is common collector. Okay. All right. Okay. So the second stage. Okay. Second stage. Okay. Since this is the output 1. Okay. This is the input 2. Okay. So input is at the gate. Okay. Where is the output? Over here. So output is always at RL. So this is output 2, right? So output is connected to the drain. To the drain. Okay. What's left over here?
Source.
Source. Therefore, it is common source. Okay. So the RC couple of this example is the connection between RC, between common collector and common source. Okay. Okay. All right. So clear on this part? Okay, so let's draw. We'll give you more example, okay, later. Okay, but now let's draw the AC equivalent circuit. Okay, AC equivalent circuit. So I need to copy first. This one. Okay, so let's draw. Okay, so for the AC equivalent circuit of this one, okay. Okay, who is still not clear on determining the comment? So please let me know. Okay, so later I'll show you more example lah. Okay, so just determine where's the input and output, and then you will know what's terminal left, and then that defines your comment. Okay, so first comment is common collector. Okay, common collector. Can you imagine on your mind right now how common collector looks like? Okay, you will have something like this, right? You have R pi. If I'm not mistaken, you have R pi. Okay, so this is for the Q1. Okay, R pi. You have R pi 1. And then you have GMV pi 1. Okay, if you still remember. All right, so this is your base, your collector. So all capacitor is shorted. Okay, all capacitor short circuit. So this capacitor short circuit, this capacitor short circuit, this capacitor short circuit, and this capacitor short circuit. Okay, DC voltage also ground. Okay, also grounded. So this will be grounded. Okay, so capacitor all short circuit. Okay, now students, at the collector over here, you have RC to the ground, and also you have this node to the ground. So what happened to the RC? At the same node over here to RC, and also at the same node over here to the ground. Therefore, what happened to RC?
So short
Short
circuit.
circuit. Okay, short circuit. Correct, short circuit. So C is grounded. Okay, so now you have ammeter. So at ammeter, okay, at ammeter, now ammeter is your output. You have RE over here. Okay, you have RE over here. And this is your V out 1. Okay, V out 1. All right, so at the base, what do you have at the base? So this is V pi 1. Okay, at the base, what do you have, student? What can you see at the base over here? You have?
Parallel with R2.
Yes, correct. R1 parallel with R2. Okay, and then what else do you have? You have R signal and also V signal. Okay, V signal. All right, that's it. Okay, that's what's left. Okay. All right, so now let's look at the Q2 pula. Okay, so this is Q1. Okay, let's take a look on the Q2. You have gate over here, you have drain over here, and you have source over here. Okay, so the output, so this is the output 1. Okay, so this is the input 1. Okay, and this is the input 2. Okay, now input 2, this is common collector, this is common source. Okay, so common source, you know that for common source, you have GMVGS. Okay, and also this one, you have GMVGS. Okay, and also you have RS. Okay, so this is what it looks like. Okay, and then this is your drain. Okay, what else do you have? So this is your source. You have, still remember, positive minus VGS. Okay, and then at the output over here, you have the RG. Okay, RG, okay, to the ground. Okay, so RG over here is R1 parallel with R2. Is it R1 parallel with R2? Oh, no, R3. R3 parallel with R4. Okay, so now where the gate goes is to the output 1. Okay, so like this. So you just tarik macam tu. Okay, so the circuit will become just like that. Okay, the same ground over there. Right, so we've done for the input 2. Okay, R3 and R4. So this is V in 2. Okay. Okay, so this is your V in 1. Okay. Okay. At the drain, what do you have at the drain? Student, what you have at the drain?
RD.
RD and RL.
Yes, RD to the ground and also RL to the ground. Okay, and you have here V out 2. Okay, you have everything there. Okay, do not forget to put your Z in 1. Okay, this is Z out 1. This is Z in 2. And this is Z out 2. Okay, Z out 2. All right. Okay, so this is Z into. All right. Okay, are you all clear? Okay, so it is not only between BJT to BJT, it can be between BJT and FET. Okay, so let's derive. Do you have any question? If no, with the AC equivalent circuit, I want to derive the voltage gain and everything. Any question? Or in the chat box? In the chat box, short circuit. You only said short circuit. Oh, I think he's referring to just now. Okay, so yeah. So let's find what is Z in 1. So what is Z in 1? Okay, Z in 1. Can someone give me what is Z in 1 from here?
Z test parallel with R1 parallel R2.
Okay, correct. Okay, so you have another one here. Allah, I need to use different color. So this is what we call is Z in B. Still remember for the common collector? Still remember?
Yes.
Yes, okay, so this is R1 parallel with R2 parallel with Z in B. Okay, so Z in B from common collector, please look at the derivation again. It is equal to R pi plus,
IB.
yes, beta plus 1 R E. Okay, all right. So that is for the Z in B. Okay, now Z out 1. Z out 1. What you do for the Z out 1? Still remember what you do at this one? So when you have common
Z test.
collector, yes, Z test. Okay, Z out 1 is equal to the Z test parallel with RE. Am I right? Okay, so Z test is equal to the R1 parallel with R2 plus R pi over beta plus 1. Okay, up to now, you have to, you already know lah, up to here, okay, how to derive. If you don't want to derive, it didn't ask you to derive, at least you know lah how to write the equation, okay? Okay, but I have explained everything on the derivation, okay? So Z into, what is Z into? Z into is more straightforward. What can you see from here? From
R3
the,
parallel R4.
yes, R3 parallel with R4. Okay, so Z out 2, also straightforward. It is equal to,
RD.
yes, RD. Okay, that's it. Okay, now let's derive for the AV. AV1 is equal to the V out 1 over V in 1. So what is V out 1? V out 1. So V out 1 is across this one. So this is your V out 1, okay, at this node. Okay, at this node. Okay, first thing, what is the current at V out 1? Tell me the current first.
GMV pi 1.
Yes. What is the resistor? What is the total resistor across that node?
Jack output 1 parallel with Jack input 2.
Can also, no, this is the voltage across that resistor. Across that resistor, not that impedance, okay? Across
Oh.
V out 1, you have, I have mentioned many times, across V out 1, you have RE and also,
Parallel Z into.
yes, parallel with Z in 2. All right, so V in 1, tell me the V in 1. So V in 1, student, is across this node. This is V in 1, okay, from the base to the ground. Okay, what can you relate at the V in 1? Can I say V in 1 equal to the V pi 1 plus voltage across RE? Can I say that?
Yes.
Yes.
Yes, right? So V out 1, V in 1 is equal to the V pi 1 and also the V at RE. Okay, the total voltage across that node. Okay, so it is equal to the V pi 1 plus GMV pi 1 times RE parallel with Z in 2, right? So you cancel out the V pi and everything. So you will get here GM RE parallel with Z in 2 over 1 plus GM RE parallel with Z in 2. Okay, remember that your objective is to simplify the equation. Okay, simplify as in you have to cancel out the V pi. So on the left is GM and their friends. Okay, all right. So let's take a look on the AV2. AV2. So for the AV2, what color is left over here? So I want to use purple. So AV2 is equal to the V out 2 over V in 2. So tell me, what is V out 2? So V out 2 is quite, I think you already know. So what is V out 2? Student? V out 2?
VGS2.
Yes, negative GMVGS2. VGS tak ada 2. Okay, times?
RD parallel with RL.
Yes, RD parallel with RL. Correct. Okay, over V into, okay, V into the same method as V in 1, the total voltage across that one. Okay, what is it? So this is your V into. Okay, now we want to see the total voltage across here. What can you see? Can I say VGS plus something here? Can I say that?
Yes.
Yes, so it is equal to the VGS plus GM VGS. Okay, it is actually equal to the VGS plus voltage across RS. Voltage across RS is equal to the GM VGS RS. Okay, cancel out VGS. Everything here cancelled out. Okay, so you will get here negative GM RD parallel with RL over 1 plus GM RS. All right. Okay. Okay, that's it. Okay. Clear on the derivation? Very much clear, everyone? Yes, very good. Okay. Why I go slow? I think I go very super slow today because I want you to get the clearly the idea, okay, what's going on here, okay, especially the total voltage across here. So when it involved with the common collector, this is actually just this is also actually the revision for single stage, right? Multi-stage, okay. So you come out again with whatever the voltage lah, apa benda tu semua kan. It's like you do revision now, okay. So that's it, okay, for the comment between common collector and common source. All right, so next one, student, is the direct couple, okay. So this one, they couple with a ring, okay. Boyfriend and girlfriend got couple, lady and a man, and the man give a ring, which is the capacitor. Okay, now there are like a soulmate. They don't need anything, so they couple. So baiklah the girl kan, the girl is I don't need anything, so just give me your heart. So you have just a wire to connect between the heart and heart. Okay. Just kidding. All right. So direct couple. So there is no capacitor between it. Okay. No capacitor between it. Just give your heart the current from the man to the girl. Oh, this is a kind girl. Okay. Okay. So now tell me the first stage is what common?
One emitter.
One emitter.
Common emitter. Think first before you sit. Okay. So common emitter. So this is the input. Okay. And the output must be connected. The output of stage 1, the base, collector, and emitter must be connected to the input of stage 2. Is connected. It's the collector. Okay. Connect to the input. Okay. So this is the input 2. Okay. And this is the output 1. Okay. What's left? Emitter. Therefore, this is common emitter. Okay. So input 2 is at base. Okay. Output 2 is where? At collector or emitter? Output is at
Collector.
collector. So what's left over here? It is common emitter. Okay, common emitter. Okay, so like direct couple, whatever, direct couple or couple with a ring, no, couple with a capacitor, okay, RC couple or direct couple. So same, you still need to define what type of common for each stage, okay, and then you draw the AC equivalent circuit. So what makes it different between the RC couple, okay, and also the direct couple? So RC couple, at the input of stage 2, there is also resistor. Okay, there is also resistor like this one. You have R3 and R4. But for the direct couple, okay, without a ring, no, without a capacitor, so there is no resistor at the input. Just direct to the base, okay, which means you can imagine that after RC1, in the next stage, you're gonna have R pi straight away. Okay, R pi straight away. So let's draw together the AC equivalent circuit. Okay, so we have more time. I better do it together with you. Okay. Okay. All right. So you said just now the first stage is common emitter. The second stage also common emitter. Okay. So let's draw the AC equivalent circuit. Okay. Okay. And all capacitor, there is no capacitor adalah. So all capacitor short circuit, and all DC voltage ground. Okay. Okay. So C1 short circuit. Okay. C2 short circuit. VCC grounded. Okay, so this is common emitter bypass or unbypass?
Bypass.
Bypass. Okay. Bypass? Are you sure? There is no capacitor over here. So if this capacitor short circuit, then you can bypass RE. But now, this one, no capacitor. Therefore, you cannot bypass RE. It is unbypass. Okay, so unbypass means that it has RE, sorry, R pi 1, base Q1. Okay, and then you have GMV pi 1. Hey, what is that? Oh my God, my my handwriting become even worse day by day. Okay, emitter you have. So this is base, collector, emitter. You have here is RE1. All right. Okay, at the base you have what? At the base you have R1 parallel with R2. Are you all bored already? Why I do this? Because I need you to be familiar. Okay, if not, I will just left you out, do it yourself, which is I know you won't do it yourself later. Okay, so let's do it together. Okay, so at the base also you have capacitor, RS, and VS. Okay, so at collector you have what? At collector,
RC1.
yes, RC1. Okay, RC1. Okay, so there is no input resistor at the stage 2. Okay, it will connect directly to the R pi 2. Okay, R pi 2. So this is Q2. Okay, and you have here GMV pi 2. Okay, this is V pi 1. This is V pi 2. And you have RE2. Okay, and over here you have what you have at the collector of stage 2. What do you have at collector stage 2? This is your collector. What do you have?
RC2 and R pair.
Yes. V out 2. Okay, so this is your V in 1. Okay, this is your V out 1. And this is your V out, V in 2. Okay, and V out 2 over here. Okay, this is your Z in 1. This is your Z out 1. This is Z in 2. And this is Z out 2. Okay, Z out 2. All right. Okay. Clear? Do you think you can, I need to copy before we, are you okay with that? Student?
Yes, okay.
Yes, great. Okay, so let's do the derivation, okay, for the input and output. Okay, so Z in 1, can someone give me what is Z in 1? What is Z in 1? Do you still remember for the common emitter and bypass, you have another terms over here, which is Z in B, still remember? Of course you still, okay? So Z in 1 is equal to?
R1 parallel R2 parallel Z in B.
Yes, R1 parallel R2 parallel Z in B. So Z in B, where you do the V total over IB, if you still remember, V total across this node to the ground, still remember? So finally, you will get that Z in B is equal to the R pi plus beta plus 1 RE1. Okay, that is your Z in B. Okay, for the Z out 1, Z out 1, Z out 1 is more straightforward. Since this is common emitter, it is equal to RC1. Yes. Z into, student, again, Z into is equal to the same thing over here. If you have Z in B, here also Z in B. Okay, it is actually Z in B2.
R pi 2.
Yes, R pi 2. This is 1. Beta plus 1. RE2. Okay, Z out 2. Can someone give me Z out 2? Same like Z out 1, therefore Z out 2 equal to?
RC2.
Yes, RC2. Okay. All right. So for the AV,
Madam, for Z input 2, you missing a plus.
where? Oh, yes. Thank you. Thank you. Correct. Got plus over here. Okay. All right. So let's do it for the AV1. Okay. Don't get bored. Okay. So this is some sort of exercise for you. Okay. V out 1 is equal to what? The total voltage across this V out 1. This one. What is the total voltage across there? Students?
Negative GMV pi 1.
Yes. Negative GMV pi 1. Okay, what is the resistor there? Total resistor?
RC1.
Yes.
RC1.
Only
RC1
RC1?
Parallel with ZN2.
Yes. RC1 parallel with ZIB2 or Z into. Okay, Z into. Divide by V in 1. So V in 1 is over here. Okay. So what can you do? Can you find the total voltage here and here? Can or not? Why we do like that?
Yes.
Because we want to simplify the equation. Okay. So V in 1 is equal to the, we want to cancel out the V pi. Okay, V pi 1. So V in 1 is equal to someone? V total. What is the V total across the base to the ground?
V pi plus VE.
Yes, V pi 1 plus VE, correct, VE, okay, VE1, okay. So now, what is VE1? It is GMV pi 1 times?
RE1.
RE1.
Yes, RE1, okay. V pi 1 can get out from here, so you get negative GM RC1 parallel with Z into over 1 plus GM RE1. So this is for the AV1. Okay, now for the AV2. Hey, I forgot. Okay. Tak apa, we go back later. Okay, so for the V out 2, what is V out 2? Same thing, my dear student, because both are common emitter and bypass. So V out 2 is equal to negative GMV pi 2 times what?
C2 parallel RL.
Yes. Okay, what is V into? So V into is the total. So this is your V into. Same thing, total V pi and total voltage over here equal to what? V pi 2 plus GMV pi 2 times
RE2.
RE2. Okay, V pi cancel out. So you will get like AV2 negative GM RC2 parallel with RL over 1 plus GM RE2. Yes, that's it. Okay. Okay, so I forgot lah just now, my dear student. Hi. Okay, so what is the AV total? I forgot since the beginning. Okay, AV total is equal to? What is AV total?
AV1 plus AV2 times.
Yes, AV1 times AV2. Okay, same goes to the previous slide. Okay, if we find, we already find each AV voltage gain. So a voltage gain, we have already find each for each stages. So the total or overall voltage gain is equal to the AV1 times AV2. All right, do you have any question regarding this derivation of the AV1, AV2, and so on for the common emitter unbypassed? Hello?
It can be any common, right?
Yes, correct. It can be any common. Correct. Okay. So for this direct couple, direct couple, it is more on straightforward. Okay, straightforward where no capacitor in between it and no input, actually no input resistance at the stage 2. Okay, it would direct to the transistor. The current also, when you find, you see the current, so current IB2, okay, so current IB2 here is actually equal to the current IC1 over here. It's the same node, okay, so it is the same node, okay, the direct. So current from here, current IB2 is actually coming out from the stage 1, so IB2 is from the stage 1. So this is combined by just a wire, okay, just a wire, right? So this is the derivation and this is also the derivation. Okay, so this is a proper drawing lah, but better explanation over here. Okay, so for the direct couple, it could be like this. So can someone give me what is the first stage over here? I just want to see what is the first stage over here. Okay, so this arrangement provide high input impedance but low voltage gain. Okay, and low voltage gain of the input stage reduce the Miller input capacitor, making this combination is suitable for high frequency application. It is suitable for high frequency application, but your syllabus just until mid band frequency. So can you tell me the first stage is what common? Look at the input first and look at the output of stage 1.
Common emitter
Common
bypass.
emitter.
Yes, common emitter bypass. So this is the input. Okay, output is at collector because it is connected to the stage 2. Okay, and what's left is emitter. Therefore, this is common emitter with a bypass RE. Okay, so in stage 2, this is stage 2. This is the, yes. Okay, so input is at emitter. Output is where?
Collector.
Collector. Okay, so what's left over here? Base. Therefore, this is common base. Okay, common base. Right. So with a bypass RB. Okay, so it can also be between common emitter to common base. Okay, it can be also between common emitter and common base. All right, so this one, in this case, it will be like this. Okay, so I think we still have more time. Do you want me to derive with you, or is it you can derive on yourself by yourself?
Derive.
Derive.
Yeah, derive with me. Okay, we have more time, right? We have like about 10 minutes. Okay. Okay, let's do it. So it'll be much clearer lah. Okay. All right. So AC equivalent circuit. Okay. So this is all capacitor short. This is common emitter. So all capacitor short. This is common base. So this is base collector emitter. As you can see in your test 2 later, please don't jump into conclusion that is the common. So please put all the notation base collector and emitter. Please carefully, okay? Think carefully, okay? To define what common is that. Okay. And emitter, this is base, this is collector. Right. So let's draw the AC equivalent circuit. So common emitter is straightforward lah. You already know and you already like master with it. Okay. So this is Q1. This is base. This is V pi 1 and okay. So at the input you have RB1 and RB2. Okay, at the base over here you have RB1 and RB2 to the ground. This is become grounded. Okay, and you have the V in. Okay, no voltage source. Okay, and at this here, so you could have imagined it. Okay, so this is NPN or PNP for the Q2. Is this NPN or PNP?
MB,
NPN.
Ah.
MB,
Are you
PNP.
sure NPN?
PNP.
PNP. Okay. So this is NPN. Current going out, okay, is NPN. Okay. Now this thing current going in. Okay. So this is how it looks like. If we draw a proper drawing, it is like this. Okay. The collector, base, emitter. Okay. From here, current for the NPN, okay, current from collector to emitter, the IC. Okay. For the PNP, current from emitter to collector. Okay. So this is the IC. Okay. Going up. Okay. From emitter to collector. Okay. Why is this important? Because when you draw later, okay, when you draw later, the GMV pi, you must know the arrow is to the left or to the right. Okay, so since oh, we haven't finished yet. Okay, for stage 1, what else do you have? For stage 1 at collector, you have RC. Yes, you have RC. Okay, and at stage 2, it is common base. Okay, you know that common base, you're gonna have the horizontal current. Okay, GMV pi. Now, my question is, this is the base, okay, the output, sorry, not base. So the input is emitter, okay, the output is collector. So tell me, the current is going to the left or to the right?
To the right.
Right.
Yes, to the right. Okay, this is PNP, to the right. Okay, from emitter to collector. Okay, from emitter to collector. Okay, so at the emitter over here, you have R pi 2. Okay, R pi 2. Okay, so since it is PNP, so plus is at emitter, therefore this is plus minus V pi 2, like that. Okay, What else do you have? RB is already short circuit because CB is short circuit. So what else do you have? R?
RC.
Yes, RC. Okay, RC2. This is RC1. Okay, and this is your V out 2. Okay, so this is your, can I write this is your V out 1? Okay, and can I use different color? This is V in 2. Okay, so you have V in 1. Okay, V out 1, V in 2, V out 2. All right, so this is your since no notation for the input impedance. Okay, so therefore this is your Z in 1, and this is your Z out 1. This is your Z in 2, and this is Z out 2. Okay, very clear? Very clear?
Yes, sir.
Okay, great. Okay, so it's a little bit more, okay, on the derivation of the voltage gain and so on, okay, before we finish our class today. Sikit lagi. Okay. All right. Okay. So this one for the Z in 1. What is Z in 1? What is Z in 1? Can someone tell me?
R1 parallel, R2 parallel, V pi 1.
Thank you. So Z in 1, R1 parallel with R pi 2. Parallel with R pi 1. This one. Okay, this is R pi 2. Okay. So Z out 1. Z out 1.
RC1.
Yes, RC1. Z into. What is Z into?
R pi 2.
So you have base over here, still remember? To the ground. You have different nodes, emitter and base. What is this, the common base, Z in for common base? What is Z in for common base? R pi 2 over beta plus 1. Still remember? Look at the common base again. Okay. Okay. Z out 2. Z out 2.
RC2.
RC2. Okay. When I say look at back again, don't look at when the exam come. Look at again. Look back again. Is look at in the after this class or tonight, whenever you're free time today. Okay, so that you won't be forgetting it forever. Okay, this is when you study, it's like trying to recall every time. Okay, so that you won't be left behind. Okay, don't keep your unknown too long. So settle your unknown in a short time. Okay. Okay, so for this V in 1, V in 1. What am I talking about? Okay, so AV1, AV out 1 over V in 1. So what is V out 1? Come on, quick. So give me the total current first. What is the total current for the V out 1? Negative GM V pi 1. Okay, the resistor. What is the total resistor over here? At the V out 1. Do I have to highlight over here? So this is V out 1. What is that?
RC1 parallel with ZN2.
Yes. RC1 parallel with Z into, okay, over, what is V into? What can you see at the V into? What are the parallel with the V into? It has something to do with the, what is,
V into or V in one, Doctor?
sorry, V in one, sorry, V in one.
V by one.
V
V
by
by
1.
1. Yes, V by 1. Okay, cancel out this one. So negative GM, AB1 negative GM times RC1 parallel with Z in 2. Okay, so next is AB2 is V out 2 over V in 2. Okay, so V out 2 is equal to what? Positive or negative?
Positive.
Yes, positive. GMV by 2 times
RC2.
okay, over what is V into over here? Can you see over here? V into, this is V into.
V by 2.
Yes, V by 2. Okay, so cancel out this one. So you will get that AV2 is GM RC2. That's it. Yeah, for the multi-stage. Okay. Okay, so we've done this. Okay, it is actually the same one here. Okay, but we explain better over here. So the AV total will be AV total. What is the AV total? So AV total is equal to the AV1 times AV2. Okay. All right. Very much clear, everyone. Are you satisfied with today? Clear on everything? Okay, great. Okay, very good.
Yes, sir.
Okay, I hope so. Okay, so yeah, I'm happy if you clear with everything. Okay, for those who were late today, so I really go slow today so that I hope you can cope with everything, the explanation. Okay, um, for the common emitter, it has high voltage gain. Common base also high voltage gain. Common emitter has high input resistance. Common base has low input resistance. And common emitter has moderate output resistance. But common base has high output resistance. Okay, so common emitter is poor for high frequency application, but common base is a very good in high frequency application. Okay, so if C is combined with the CB, a device has a good frequency behavior, right? So for the example for direct couple, can I left this with you? So the next class we will continue from here. So please, before we end our class, okay, can you draw the not draw later? I mean, can you determine first what common for the stage 1? So this
Common
is
collector.
uh but correct. Okay, so the input is at the base, the output is collector, connect to the stage 2. Therefore, what's left is emitter. So the common for stage 1 is common emitter. Okay, what is for the stage 2? Stage 2. So input
Common
here,
base.
yeah, input here, output is at RL at the this is emitter, this is collector, so therefore this is common base. It is between common emitter and common base. Can I left this with you so that you can draw the AC equivalent circuit? Okay, we will continue from here in the next class. Okay, is that okay?
Okay.
All
Okay,
right.
Doctor.
All right, great. Okay, since you already very much clear again, so you do it. Okay, so just want to show you. So for the next class, we will discuss on the MOSFET. Okay, MOSFET tutorial. Okay, for the next class, we will be discussing on the MOSFET tutorial. Okay, please remember that. And also our revision class on 8th June. Okay, please try first the revision question. It is very worth of trying and good preparation for your test 2. Okay, And yeah, that's it. Okay, all. I think that's it for today. I will upload the slide of today's class by today. Okay, so that you can do revision. Okay, I think that's all. Thank you all. Bye.
Thank you,
Thank you,
Doctor.
Doctor.
Yeah, take
Thank you,
care.
Doctor.